Question number 1.17. A point charge plus 10 microcoulomb is at a distance 5 centimeter, which is shown here, right? Above the center of a square. So that square I have drawn here. So in this square you can see there is a charge which is lying above it 5 centimeter. What is the magnitude of the electric flux through the square? See, whenever we want to use Gauss law to find the flux, we need 3D surface, right? Without 3D surface you cannot apply Gauss law. So what I have done, here it is given one square. So I am making a cubic Gaussian surface. See, Gaussian surface I can choose by myself. It's my choice, right? So what I have done, I have made a cube such that, right, the charge now inside a imaginary cube. It is actually above. It is not actually inside a cube. It is actually above a square. Right here you can see there is a square. The charge is actually above the square. But what I have done, I have made an imaginary cube over it. So now the charge is exactly in the center of this imaginary cube. So for a Gauss, if we apply Gauss law, then from Gauss law it is flux is equals to Q by epsilon naught. And here the charge Q should enclose in the 3D surface. It is a Gaussian surface, right? So if this square is a part of this cube, then how much flux will come out of it? Q by epsilon naught from this cube. But now this flux is divided between 6 surfaces, right? It is divided between 6 surfaces, right? That already we have done in the previous question. So this flux is divided between 6 surfaces. So the flux through the single cube is Q by epsilon naught, but flux through each surface is divided by 6. So your final answer will be, so the charge is given 10 microcoulomb, 6, and here the value of epsilon naught. If you solve this, you will get 1.88 into 10 raised to 5 Newton meter square per coulomb